All right, good morning, guys. It's 8:45. We're gonna get started. All right, so if you were on the Learn course page, hopefully you read the posting for today. So if you remember last week on Thursday, we started with lesson 2, which was using variables. Today, I'm just gonna continue going over the remainder of those slides, and then during the independent math time for today, you guys are gonna be working on that mastery test for using variables. All right, so anybody that's already finished with the lesson, right? If you want some extra practice, I'm gonna go over it at the end as well, but just so that you're not watching me go over stuff that you've already done yourself. If you just scroll down a little bit here, you're gonna see that I also posted a separate assignment. So it says Evaluating Expressions Worksheet. If you click on that, it should take you to the content section. I'm not sure, you might have to log into a Google account or something, but I think you might have to make a copy of it. This is my first time posting an assignment like this here, but this is just another way for you guys to practice this. And again, I'm gonna spend some more time at the end of the lesson going over it, but I wanted to show how you can get to this now so that if you've already done the lesson, you're finished with it, you have something else to do right now, all right? So again, if you're already done with the lesson, get started just working on these here. And this is just evaluating expressions like we did last week, all right? Again, I'm gonna revisit that at the end of the lesson. So everybody else, we're following along, and just please let me know if you have any questions as we go, right? This is where we left off last week on Thursday. So we had been going through, looking at some expressions, replacing the value of x with a number, and then figuring out what the value was. So before I go on, just please let me know, did anybody have any more questions on this activity over here? All right, just feel free to write it in the chat, and I'll just backpedal and step back if I do see any questions pop. Actually, okay, so Anthony, you got a question. Can you tell me what the question was? Or Alfie?
That for extra credit,
Which one?
worksheet.
The evaluating expressions? That's just more work. So if you've already finished this entire lesson, right? Because usually ideally what we should do is try to work on the lesson your own during independent math time. So if you finish that, you're gonna start working on this here. Right? Yeah, so work on it. And again, it's not about extra credit. Summer school is basically like pass or fail. So we're just looking to collect as much evidence as we can to put into your portfolio to show that you have been learning over the summer and that you're ready to go on to the next grade, right? So more work's definitely not gonna hurt you, and you definitely want to go through, right? Okay, so I'm just gonna go ahead and look at the next couple of slides. All right, so this slide over here, it says algebraic expressions can also be found in mathematical formulas, of which can be applied to everyday problems, right? Look at this formula, perimeter of a square. So they don't give you any pictures here. I'm gonna try to explain this slide here a bit because it might be a little bit confusing if you're only just kind of reading it without any context here, okay? So first we're thinking about a square. So I'm just gonna draw a square here. Right, so that is my really bad square, right? Now, a square we typically know always has the same length on each side, right? So if I had this square here and it had like, say, this side was 5, I also know, okay, so this side is also 5, this side is also 5, this side is also 5, right? If I then wanted to find the perimeter, does anybody remember what's the mathematical definition of perimeter? What does that mean if I'm talking about a two-dimensional shape like a square? All right, we can type in the chat. Anybody wants to quickly unmute and just say it out loud. I'll give you a couple of seconds to think about it, see if anybody remembers. Okay, thanks for letting me know if we don't know. So this is good, right? Because you might be reading through this and say, wait a second, I don't know what perimeter is. So then this whole thing makes no sense, right? In math, when we talk about perimeter, a perimeter is basically the length going around the outside of a two-dimensional shape. So the perimeter for this square, I'm thinking about the distance from starting here, working around this way, this way, this way, this way. Like if I was to picture myself walking around the outside of the square, how far would I walk, right? So it's not multiplication. The perimeter is actually this length. So I would say walk, let's say this is 5 feet. Then I walk down another 5 feet this way. I walk over another 5 feet. I walk up another 5 feet. How far did I walk? In that case, it's actually 5 plus 5 plus 5 plus 5. All right? So this here is perimeter, right? Walking around the outside of the shape. So different example. If I had another square, right? Let's say this is my other square. It has a side length of 10, right? So I know all squares have the same length going around the side. So if this is 10 here, this is also 10, this is also 10, this is also 10, right? So again, perimeter is the length around the outside. So 10 plus 10 plus 10 plus 10. Right? 10 plus 10 plus 10 plus 10 is just 40, right? Now what you also might say is, okay, I'm just adding 10 4 times, so I can really just say, okay, that's just 4 multiplied by 10, right? Now, again, let's look at a different square. Let's say this is my square, and I say, okay, this square has a perimeter, sorry, it has a side length of 7. So I don't have to specify this is 7, this is 7, this is 7 if I'm telling you that this is a square, right? So now I say, okay, I know I would have to take 7 plus 7 plus 7 plus 7, or think about what I saw before. It's just going to be 7 multiplied by 4. That's going to give me the perimeter, which in this case is 28. All right? So that would work with any single square. If I want to figure out what the perimeter is and I know how long the side length is, I do 7 times 4 to get 28. So what they're doing here is they're generalizing it. They're saying here that we now have a square, but we're going to use a variable to represent how big that side length is, right? So now I have this square, and instead of giving you a number, they're saying that number is S. So this square has a side length of S, whatever my unit is, feet, inches, yards, miles, whatever it is, right? But the way that I find the perimeter of that square is I just take 4 and I multiply it by however long the side is. All right, so now this gets into evaluating expressions like we talked about last week. So they're saying, okay, so let's say that I know that the side length of this square is actually equal to 5, sorry, those S's and 5s look similar, 5 centimeters. So if I know that I have this expression here, 4 times S is going to give me the perimeter, and I know that S is in fact 5, all we do is we substitute or we replace the value of S with the number 5. So it turns into 4 times 5, which gives us 20. Right? And these other expressions here are just different expressions. So S squared, right? Remember we talked about exponents last week? And that means S multiplied by S. So if I wanted to find the area of this square here, remember area is a measure of how much stuff fits inside of a square. So in this case here, it's going to be S times S, or it's 5 times 5. The area for this square would be 25. Right? And in math, you're going to start to see different expressions, right? Once you get to 8th grade math, you start looking at volume of shapes. So we might say, okay, so just to give you an idea of where things are headed eventually, you'd say, okay, I have this shape here. This is a cylinder. And to figure out the volume is how much stuff fits into something. You need to know how far you go across the top of the cylinder, how tall the cylinder is, and this is going to look confusing, but just so you know, it's going to look like pi times the radius squared times the height, all divided by 3. So things start looking a little bit more complicated, but in essence, once you're evaluating it, you're going to do the same thing. You would figure out how long is this, replace that number here. How long is this, replace that number here, then do some math to figure it out, right? But this here is getting into things that are a little bit more advanced. All right, so the following slide here is going really based off of what we just saw on that last one there. So it says here that the area of a square, remember I just showed you that there, I had this square, area is defined as the amount of stuff inside of a two-dimensional shape. So this square has a side length of S going all around. So to find the area of this square, it's just the side multiplied by itself. So S times S, or you can express that with an exponent as S squared. What it's telling us here is that we actually know that that side length of the square is 6 centimeters. So if we know that S is actually equal to 6, can anybody tell me what's the area of this square going to be? And basically what we need to do is just take this value of 6 and replace it in the equation. Okay, thank you, Jaden. Got it right. So I'll let you guys figure that out. If you can't figure it out, and I've got the chat set to host only right now, just type it in if you got it. If you're not sure how to find it, please let me know, all right? And okay, something else that I saw some people having trouble with is it says do not include units. So in this answer, you would only have a number, right? Some of the other questions with this program, they might want you to put units in. All right, so if we actually just take a second to step back to the last question. Right, over here, we got an answer for the perimeter of this square was 20, right? But sometimes it might mark you wrong. It's actually gonna end up being 20 what? So every time you have a word problem, you have to think about context, right? I think we were talking about a square. We said that this square over here had a side length of 5 centimeters. So your final answer should actually have units. Your answer here would be 20 centimeters. So sometimes if your answer is marked incorrectly here, just double check to see if you need to put units in. Do you need to write centimeters? Do you need to write feet? Just specify what does the number that you're writing actually mean, because almost all of these questions are going to have some kind of context to them. All right, so we should have finished this one then our own. This activity here is just asking you to match up what you see on the left-hand side with these things on the right-hand side. So I'll just do the first one here together with you, and then ideally we should be able to figure the rest of these out on our own, kind of by guess and check, elimination, see what makes sense where. So this one over here, it says product of 4 times x divided by 7, right? Remember, product means multiplication. Now, this is part of the problem once we start getting into algebra, is that we're talking about x here. X is a variable. So if you're still using an x to represent a product, it becomes really easy to confuse. Like say if I wanted to write down 4 times x, right? Unless you're making your multiplication symbols really small, your variables really big, at some point you're gonna mix these up and confuse multiplication for a variable. So I think I mentioned this last week. That's why once we start getting into 7th grade math, 8th grade math, we really don't use this x for multiplication anymore. We just start using a dot or nothing at all. So 4 times x I would write as 4 dot x, or simply just 4x. All right, so again, product, I'm looking for multiplication somewhere. So, check in the bedroom, Wolfie. So I'm looking for, sorry, this is something weird. Yes. Sorry, just having some trouble with my pen here. Give me a second. So again, I'm looking for a product. So multiplying, it says 4 times x. So 4 times x divided by, so divided by 7. I'm looking for something that looks like this here. Now, again, if I'm looking through here, I don't exactly see that, but where do I see a 4 and an x? Okay, so over here I see a 4 times an x. Okay, good, Jaden. Over here I see another 4 times an x. So this is 4 times x multiplied by 7, right? This one has no division in it. This one here, this is a fraction. Only thing that you always have to remember is that fractions you can read 2 ways. You can say 4x over 7, or you can say 4x divided by 7. So fractions mean division, all right? Try to remember that. So that means that this one here would end up going here. Good if you got that. Now try and figure out the rest of them on your own, okay? All right, AJ, I'll go back to that one in a second. Anthony, yeah, try it out. All right, so I believe we're up to the summary slide already. All right, so just to summarize, we did 2 main things here. One thing that we did is we practiced going back and forth between expressions that are written in words and writing them out in algebraic expressions. So some things to remember, like plus, add, sum, multiply, product, times. They're kind of words that imply when you're talking about addition versus subtraction or multiplication versus division. And then another thing that we also did was we practiced evaluating expressions, right? I think that's the main focus of this one here, because that's going to be a really big thing when you guys are working towards pre-algebra and eventually algebra, right? So it's starting with an expression like, say, I don't know, 3x plus 4, giving a value of x, let's like say 2, and substituting it in so that we can evaluate that expression and figure out what the value is, all right? So that's kind of like the main thing, and that's what I want you guys to focus on mostly when you're trying to practice, is making sure that you understand how to evaluate these expressions. Give me a second, somebody's in the waiting room. All right, so we're almost done with the live portion for today. If you're done with the lesson, the next thing would be for you to go ahead and get started with the mastery test. All right, again, make sure the goal for the mastery test is to try and get at least an 80. You have multiple attempts to do that. If you get locked at some point, you should have 3 attempts, but sometimes it's been locking for students for some reason. Just shoot me an email. I can take a look at what you've done, try to give you some feedback, and then unlock it for you, right? And then if you want some extra practice, right? Again, over here, this here is some practice. You can find it on the iLearn page with just evaluating expressions, all right? This year, I think this is something that I actually created for my own 7th grade students that I had last year. So this will be a really good practice for you. There's a lot of questions here, so don't feel like you have to do all of them, but I want you to try as many as you can. It goes on for 3 pages. The last page starts to get a little bit harder, but I believe that's something that you guys can all do, right? You start with an expression like the one that I have right here. I'm giving you a value over here, right? So I'm saying 7 plus x.
But why are you adding more homework? Because you already did the
stuff.
using variable. Wait, is this different?
This is what I showed you earlier.
Ew.
Yeah, it's not an extra one. So this is that one that I showed you. So this is more, right? If you've already finished the lesson, right? You finished the mastery test. Ideally, we're supposed to be working on math until 10:30 today, right? So if you need more practice, because more practice is always good, then we can work on this here, right? If you're not done yet with this lesson or this mastery test, or you have other stuff that you haven't finished, I'm not expecting you to go ahead and rush through and try to finish this, right? I want you to get as much from the course as you can. So this is kind of just an extra support for people that need more practice, or if you just want, you know, more work in your portfolio to show what you're learning, right? It's not something that should be too difficult. I'm not trying to stress you out. I'm trying to help you guys learn more, if that helps. All right, so I'm gonna end the recording for now.